AMD is working on a version of FSR4 for older Radeon graphics cards, and today I'm going to test a work-in-progress build to see how it's shaping up. Is this version as good as FSR4 in terms of image quality? How does it perform on RDNA 3 and RDNA 2 GPUs? And on the balance of things, is it going to be a viable option for upscaling if AMD releases it officially? I'm going to answer all of those questions today. Now, as we know, FSR4 is only officially supported on the very latest RDNA 4 graphics cards like the Radeon RX 9070 XT. This is because FSR4 uses the FP8 data format to accelerate the AI upscaling algorithm, which is only supported in AMD's RDNA 4 architecture. But AMD has been working on a version of FSR4 that uses the INT8 format instead, which is more broadly supported. AMD introduced support for INT8 back with the RDNA 2 architecture, so theoretically, the INT8 version of FSR4 could work on GPUs as old as the RX 6000 series. The only reason we know AMD are working on an INT8 version of FSR4 is because they published source code for it to their GPU Open GitHub repository. People quickly downloaded the INT8 model library before AMD removed it, and then compiled that library into a working FidelityFX DLL that can be inserted into games. This is how we're able to test the INT8 version before AMD makes it official. It's been a community effort over the last month or so to get it working, so credit to the people who've been working hard on it. But before we get to the testing, today's video is sponsored by Gigabyte's GeForce RTX 50 series gaming laptops. The Aorus Master 18 and 16 are super high performance beasts with up to RTX 5090 laptop graphics, stunning 240Hz HDR displays, and top-end features like a PCIe Gen 5 SSD and Wi-Fi 7. The Aero X16 Copilot Plus PC is the perfect choice for gamers and creators on the go, with a portable chassis, up to RTX 5070 laptop graphics, and a high-resolution Pantone validated display. The gaming A16 and A16 Pro are also available with up to RTX 5080 laptop graphics, wind force cooling, and overall great bang for buck. With NVIDIA GeForce RTX graphics, you have access to superb performance and cutting-edge features like DLSS 4 transformer model upscaling and 4x multi-frame generation. To learn more about Gigabyte's RTX 50 series gaming laptops, check the links in the description. Getting FSR4 working on RDNA 3 GPUs is surprisingly easy. Once you've downloaded the INT8 DLL file, all you have to do is find a game that already supports FSR 3.1 and copy the DLL into the game's directory, overriding the existing FidelityFX DLL. This replaces FSR 3.1 with FSR 4 in the game, and depending on how the game has implemented FSR 3.1 support, it will even say in the game's settings UI that it's FSR 4 now, not FSR 3.1. Getting FSR 4 running on RDNA 2 is a little more tricky given some driver issues, but I used the guide from Ancient Gameplays to get it working, which I'll link below. I'm going to run through some quality comparisons and performance numbers in a moment, but a quick disclaimer before doing so. This is testing of what appears to be an in-development version of INT8 FSR4, so we don't know whether it will be representative of the final version if released to the public. AMD could optimize it further before launch, but it still gives us a look at how it's shaping up so far. The first thing I want to look at is whether the FSR4 INT8 model is the same as the FSR4 FP8 model, and so delivers the same image quality. My guess is that it's not the same. The model has probably been modified or downgraded in some way to use INT8 instructions, so let's take a look. Here I'm comparing the FSR4 INT8 version running on a Radeon RX 7900 XTX to my FSR4 FP8 captures from my initial analysis a few months back, running on the RX 9070 XT. At high render resolutions like 4K quality mode, the INT8 and FP8 versions are remarkably similar in visual quality to the point where most people will find the two virtually indistinguishable. There are some minor differences, so the two models are not exactly the same, but the INT8 version, at least in this configuration, is a very good proxy for regular FSR4 that we analysed earlier in the year. It's pretty clear from looking at the INT8 version in depth that it's the same type of algorithm as FSR4 FP8. By that I mean the general output, the strengths and weaknesses of both versions are similar. Both versions are capable of reducing or removing TAA-related blur in motion, both are quite good at handling disocclusion, and both are a significant improvement on FSR3 in areas like shimmering and transparencies. This doesn't appear to be a situation where the INT8 version is a complete reworking of the technology that's being labelled FSR4 when really it isn't. The main difference between the two models is how they handle detail reconstruction, especially at lower render resolutions. The FP8 model is better at determining which pixels should form the final image and what sorts of elements are truly being rendered. This isn't often a problem at 4K using the quality mode because the INT8 model has enough data to work with, so I only saw minor differences. For example, when transparent objects would overlap, the FP8 model provided better definition and less blur. The FP8 model offers progressively better image quality than the INT8 model as you reduce the render and output resolutions. At 4K using the performance mode, the two models still look similar, but the FP8 model's relative output is a little better here than we saw comparing quality modes. At 1440p quality mode, we start to see more noticeable differences, including an overall sharper presentation with the FP8 version. And then as we move all the way down to 1440p performance mode, I think it's pretty noticeable in this configuration that the original FP8 image is less blurry, more detailed, and sharper overall. That's not to say the INT8 version is completely hopeless at low render resolutions like 1440p performance mode, because it still holds up pretty well compared to how FSR3 looks. But it's clear that this model is not as adept at handling low resolution upscaling as the full-fat FSR4. The AI model size has probably been reduced with the INT8 version for performance reasons, and is just not as good in these situations. I didn't end up testing 1080p upscaling for this video, but I suspect if we looked at those configurations, we'd see a continuation of this pattern. Now the good news, I guess, is that this reduction in detail and sharpness seems to be the main difference in image quality. At 1440p, the INT8 version is not noticeably less stable, so the level of shimmering and aliasing is preserved across the INT8 and FP8 versions. It's just that the INT8 version is less sharp and detailed. This is a much better outcome than the reverse situation where the sharpness is preserved but the image gets less stable and more shimmery, because that sort of artifact is extremely noticeable and one of the main reasons why FSR3 at 1440p looks so bad. And to some degree, comparing the versions at 1440p using the performance mode is nitpicking, because we don't recommend using this mode even for full-fat FSR4 or DLSS4. In configurations gamers would most likely choose to use, like say 4K balanced or 1440p quality, the INT8 and FP8 versions of FSR4 are pretty close, and at the highest resolutions, much closer than you might think. I suspect some of you will not have been able to notice the differences in some of the examples I've shown so far. The next part of the puzzle is performance. The FSR4 INT8 model is harder to run on RDNA3 and RDNA2 GPUs than the FSR4 FP8 model is to run on RDNA4. Let's run through some performance numbers so you can see what I'm talking about. In Ratchet & Clank Rift Apart at 4K on the RX 9070 XT, FSR4 and FSR3 offer somewhat similar performance. At worst, FSR4 is half a quality tier slower. So for example, the performance uplift you get using the FSR4 balanced mode is between the uplift of FSR3 quality and balanced modes, hence half a tier slower. It doesn't give you quite as much of an uplift on the same mode. So this is the baseline we have for the full fat version of FSR4. If we now look at FSR4 INT8 on the RX 7900 XTX at 4K, also in Ratchet & Clank, we see a greater performance impact. In this configuration, FSR4 is one full tier slower, so the uplift seen using the balanced mode is similar to FSR3 using the quality mode. I've also included XeSS DP4A results in here, given a lot of RDNA3 owners use that technology over FSR3, and we see that FSR4 balanced is similar to XeSS quality in performance. The INT8 version is even slower on the RX 6750 XT and RDNA3 card when looking at 1440p performance. Here, FSR4 performance mode is a little slower than FSR3 quality mode and similar to XeSS ultra quality, so it's quite a punishing algorithm on this older mid-range GPU. In The Last of Us Part 1, full FP8 FSR4 on the 9070 XT is about a tier slower than FSR3, meaning FSR4 balanced is equivalent to FSR3 quality. On the 7900 XTX, FSR4 INT8 is 2 tiers slower, so the performance uplift of FSR4 performance mode is in line with FSR3 quality. I still saw a 23% performance increase from FSR4 quality upscaling, which isn't too bad, but that's not all that close to the 44% increase from FSR3 quality upscaling, showing us how much more taxing the newer algorithm is. And in this title, I saw pretty similar results from the RX 6750 XT at 1440p. The FSR4 INT8 performance mode was a little slower than FSR3 quality, and we got just a 15% improvement from FSR4 quality mode. Horizon Zero Dawn Remastered doesn't benefit as much from upscaling as other titles I've tested. On the 9070 XT, we see FSR4 running half a tier to one full tier slower than FSR3. On the 7900 XTX, we're pretty much at 2 full tiers slower, meaning FSR4 INT8 performance mode is a match for FSR3 quality mode and XeSS quality mode. We see just a 10% increase from using FSR4 quality mode, which is not a significant gain, though image quality is very good. The 6750 XT is in an even worse position. We effectively see a 3 performance tier difference between FSR4 and FSR3 because FSR4 performance mode is still a decent amount behind FSR3 quality mode in FPS output, only matching XeSS ultra quality. The last game I looked at for performance numbers is Spider-Man 2 on the 9070 XT. FSR4 was about 1 quality tier slower than FSR3. When we look at the 7900 XTX, we see FSR4 INT8 running 2 quality tiers slower. So again, FSR4 performance mode is a match for FSR3 quality and XeSS quality. The 6750 XT also shows about that 2 quality tier performance difference at 1440p, so a little better than Horizon Zero Dawn, but you'll only get about a 10% performance improvement running the quality mode. In general, with how the INT8 mode currently runs based on AMD's published early source code, with FSR4 you'll probably need to drop 2 quality modes to get the same performance uplift as the upscaler you were using previously. So if you opted for FSR3 quality mode or XeSS quality mode in games today, when switching to FSR4 INT8 you'll need to use the performance mode for the same FPS uplift. Alternatively, you can use a higher mode, but you'll have to accept less of a performance increase relative to native rendering. The quality mode may only provide a 10 to 20% improvement, whereas 30% is common using full FSR4 on an RDNA 4 GPU. Let's jump back into some image quality comparisons now to explore all of these technologies. I'll start first with everything set to the same labeled mode, in this case the quality mode. Note that FSR4 INT8 will run worse than the other techniques, but this is a good idea of what would happen if you opted to use a typical level of upscaling and you weren't overly concerned about the magnitude of performance increase. The order of best to worst image quality is pretty clear when viewing the examples like this. FSR4 delivers the best results, with the FP8 mode outperforming the INT8 mode slightly, especially at higher resolutions. FSR4 INT8 is then superior to XeSS's DP4A mode that runs on RDNA 3, and in clear last place is FSR3, which delivers the worst image quality. XeSS DP4A is closer to FSR4 INT8 than FSR3, especially at lower resolutions. The main reasons why FSR4 INT8 looks better than XeSS, and especially FSR3, is down to less blur in motion, a greater level of detail, and better stability. The difference between FSR4 INT8 and FSR3 stability is night and day. That's clearly the biggest improvement comparing these technologies, but FSR4 INT8 is also better than XeSS in this department across most of the examples I looked at. FSR4 INT8 is noticeably sharper than XeSS and FSR3 as well. XeSS here isn't bad, but even looking at something like 1440p quality mode, FSR4 INT8 has the edge. I also looked at a few examples where I bumped XeSS up to ultra quality, which uses the same render resolution as FSR using the quality mode. This didn't make much of a difference, and I would still prefer FSR4 INT8 over XeSS at the same render resolution. Basically, this just confirms that the FSR4 INT8 model is the best available option in terms of image quality on GPUs that don't support FSR4 or DLSS, and it's what I'd pick to use on RDNA 3 and RDNA 2 graphics cards. But what if we normalize for output performance? In this situation, we'd be comparing FSR3 and XeSS using the quality mode to FSR4 FP8 using the balanced mode and FSR4 INT8 using the performance mode. Does this still make the FSR4 INT8 model viable? At 4K, the answer is definitely yes. It does change the margins a bit between the various models and extends the lead the FP8 model has over INT8. But typically, even the FSR4 INT8 4K performance mode is a good option. In all scenarios, I preferred FSR4 over FSR3 running in the quality mode, as FSR4 is sharper, more detailed, and has noticeably better stability. This is a big win for gamers who typically choose to use FSR and for games that don't support other technologies like XeSS. FSR4 INT8 performance mode is better than FSR3 quality mode, which is similar to what we found with the full FSR4 version. This alone is probably why RDNA 3 gamers are desperate to gain access to FSR4. As far as I see it, compared to FSR3, you've got a choice between a higher quality but slower upscaling option in FSR4 quality mode, or a similar performing but also better quality upscaling option in FSR4 performance mode. Either way you configure FSR4's INT8 version, you should be getting a better experience, and I would only fall back to FSR3 if no FSR4 mode was available to offer the performance you're after. FSR4's INT8 mode in this performance normalized comparison is also typically better than XeSS, even though we're comparing performance versus quality upscaling. FSR4 tends to have a lower amount of shimmering and aliasing compared to XeSS, while also delivering better sharpness and less blur. It's a much closer battle than FSR4 versus FSR3, and there are times where XeSS in specific areas to the image produces a better result due to its higher render resolution, but on the balance of things, I would opt to use FSR4 at a lower mode than XeSS on a higher mode. Much to my surprise, the benefit of using FSR4 INT8 over other upscalers grows at 1440p. Here I would say this is clearly the preferred choice if you don't have access to FSR4 or DLSS4. Now FSR4's FP8 model is more noticeably superior in these configurations than it was at 4K, with a sharper and clearer presentation in motion than FSR4 INT8, but the INT8 model puts up a good showing. In particular, it's clearly superior to FSR3 at 1440p, even comparing performance versus quality modes. In fact, it destroys FSR3's image quality. Once you use the INT8 variant at this resolution, there is no way you'll ever put up with FSR3 again. I also generally think FSR4 INT8 delivers better image quality than XeSS when performance normalized. XeSS DP4A struggles in some areas at this resolution, even using the quality mode, like with grass, which is prone to a lot of shimmering and grain. FSR4 is the more stable upscaler, despite rendering at a lower resolution, and it usually delivers a similar or better level of sharpness with less blur. Again, there can be instances where XeSS has better detail, but in my opinion this is not enough to offset the worst stability, and when actually playing these games, FSR4 INT8 feels like it's producing a higher resolution output. This is especially good news for people with lower-end RDNA 3 and RDNA 2 graphics cards who are more likely to be using FSR4 INT8 at 1440p and 1080p. This should be the best option for gaining more performance, even if the performance cost to using this upscaler is higher than other technologies. Based on what I've seen today, there is no doubt that AMD should release the INT8 version of FSR4. The in-development build that I analysed, thanks to AMD's source code blunder, is a significant upgrade on FSR3 and an improvement upon XeSS that owners of older Radeon cards would often opt to use. For those with RDNA 3 and RDNA 2 GPUs, FSR4 INT8 would be the go-to choice for upscaling in modern titles. It would extend the life of these products and be a great way to support loyal Radeon buyers. I was pretty skeptical about whether AMD could bring FSR4 to older graphics cards in a way that would work well. I thought they could probably get it working in some way, but that the algorithm would prove to be too taxing without the hardware acceleration capabilities introduced in RDNA 4. This is partially true. FSR4 INT8 uses a downgraded algorithm that is more taxing than FSR4 FP8, but despite this, it's still a good upscaler. I guess I underestimated how bad FSR3 looks at resolutions like 1440p and how much scope for improvement there was, even if the heights of full-fat FSR4 are not reached. In many situations, it's very impressive how close the INT8 version gets to the FP8 version in image quality, so even if it's a more performance-intensive technology on RDNA 3, you might still want to sacrifice a few FPS to enjoy its visual output. Plus, if it's accessed through a toggle where you can choose to use FSR4 or choose to fall back to FSR3, there's no real downside to providing it as an option. The question is whether AMD will release it. AMD didn't respond to my questions about this before publishing, but this is official AMD code, so they could release it at any time. One reason they might choose not to is to avoid cannibalizing RDNA 4 sales, given that FSR4 is a major selling point. If FSR4 was available for RDNA 2 and 3, owners of those cards might opt against upgrading to RDNA 4. I think that would be a pretty bad reason. First of all, it would be anti-consumer to withhold the tech for business interests, but beyond that, AMD will also just be annoying existing Radeon owners. Supporting those customers is probably going to result in better brand loyalty and repeat purchases down the line. Also, it's not like AMD sold loads of previous gen graphics cards. From an upgrade sense, FSR 4 is much more important in the battle between Radeon and GeForce, not new Radeon versus old Radeon. Anyway, I'll be keeping an eye on this one to see whether AMD releases it officially, and when that happens, I'll revisit it to see what has changed compared to this in-development version. But so far, what we've seen based on this source code that AMD accidentally published, the INT8 version of FSR 4 is certainly looking very good. So anyway, that's it for this analysis, this video. Thanks for watching to the end. If you do want to support Hardware Unboxed and the independent testing that we do right here on the channel, consider supporting us via Patreon. Links to that is in the description below. If you sign up, you get access to some pretty cool benefits, Discord chat, monthly live streams, BTS content, and plenty of other good stuff. So thanks for watching, and I'll catch you in the next one.